NVIDIA's new AI computer is insane, the desktop supercomputer that changes everything. Artificial intelligence is no longer confined to massive data centers. NVIDIA has just introduced one of its most ambitious computing platforms ever, a compact AI computer that brings supercomputer-class performance directly to your desk. Called the DGX Spark, this tiny machine is designed for developers, researchers, AI startups, robotics engineers, and anyone building next-generation AI applications. Despite its small size, the DGX Spark delivers performance that would have required racks of enterprise hardware only a few years ago. It's a bold vision from NVIDIA: make local AI development as accessible as using a traditional desktop PC. A supercomputer that fits on your desk. At first glance, the DGX Spark looks like a premium mini PC. Under the hood, however, it's an AI powerhouse. Powered by NVIDIA's GB10 Grace Blackwell superchip, the system combines an ARM-based Grace CPU with Blackwell GPU architecture in a unified design optimized specifically for AI workloads. The result is a machine capable of delivering up to 1 petaflop of FP4 AI performance, making it one of the most powerful desktop AI computers ever built. Unlike conventional workstations that rely on separate CPU and GPU memory pools, DGX Spark uses 128 gigabytes of unified coherent memory, allowing enormous AI models to run efficiently without constant data transfers. Built for massive AI models. One of the biggest limitations of current AI PCs is memory. Large language models require enormous amounts of RAM and GPU memory, forcing many developers to rent expensive cloud servers. DGX Spark changes that. The system can locally run inference on AI models with up to 200 billion parameters, enabling developers to experiment with advanced LLMs while keeping their data private and eliminating cloud latency. For AI developers, this means running advanced LLMs locally, faster inference, private AI workflows, lower long-term cloud costs, real-time experimentation. Designed for the AI era. NVIDIA isn't marketing DGX Spark as a gaming PC. Instead, it's built specifically for AI development across industries including robotics, autonomous vehicles, computer vision, scientific research, healthcare, financial modeling, edge AI deployment, agentic AI systems. The system comes preloaded with NVIDIA's complete AI software ecosystem, including CUDA, TensorRT, AI Enterprise, and frameworks like Isaac, Metropolis, and Holoscan, allowing developers to begin building immediately. Why unified memory matters. Traditional desktop PCs force data to move back and forth between CPU RAM and GPU VRAM. That movement creates bottlenecks. DGX Spark removes much of this overhead by using a unified memory architecture where CPU and GPU access the same memory pool. Benefits include faster AI training, larger context windows, improved inference speeds, better performance for multimodal AI, simplified software development. This architecture resembles Apple's unified memory approach, but scales it for enterprise-grade AI computing. Perfect for AI developers. Cloud computing has transformed AI, but it isn't perfect. Developers often face GPU shortages, high cloud costs, internet dependency, privacy concerns, slow iteration cycles. DGX Spark addresses these issues by allowing developers to prototype, fine-tune, and test sophisticated AI models locally before deploying them to larger DGX clusters or cloud infrastructure. Enterprise-class AI at home. One remarkable aspect of DGX Spark is that it brings technology previously reserved for enterprise data centers into a desktop form factor. Tasks such as AI coding assistance, image generation, video generation, scientific simulations, financial forecasting, medical research can now be performed locally with extraordinary speed. Universities, research labs, and AI startups have already begun adopting DGX Spark for cutting-edge research projects. Beyond chatbots. NVIDIA envisions these systems powering the next generation of autonomous AI agents. Instead of simply answering questions, future AI systems will plan tasks, write software, analyze documents, control robots, automate business workflows, manage personal knowledge bases. DGX Spark provides enough compute to prototype many of these agentic workflows without relying entirely on cloud infrastructure. The competition is catching up. NVIDIA's success has already sparked fierce competition. AMD recently introduced its Ryzen AI Halo developer platform, while several major PC manufacturers, including Dell, Asus, HP, Lenovo, and Acer, are building systems around NVIDIA's AI hardware. Meanwhile, NVIDIA's newer RTX Spark platform aims to bring similar AI capabilities into mainstream laptops and desktops. Is it worth it? DGX Spark isn't intended for everyday consumers checking email or browsing the web. Instead, it's aimed at AI engineers, machine learning researchers, software developers, universities, robotics, companies, AI, startups, enterprise, R&D teams. For these users, the ability to run enormous AI models locally can dramatically reduce cloud costs while accelerating development cycles. The DGX Spark represents more than just another powerful computer. It signals a shift toward personal AI supercomputing. By packing petaflop-class performance, 128 gigabytes of unified memory, and support for AI models with hundreds of billions of parameters into a compact desktop device, NVIDIA is redefining what developers can accomplish without relying on massive cloud infrastructure. As AI becomes central to software development, robotics, healthcare, scientific research, and enterprise automation, local AI computing is poised to become increasingly important. NVIDIA's vision is clear. Instead of renting intelligence from the cloud, developers will increasingly own it on their desks. If that future unfolds as expected, the DGX Spark may be remembered as the computer that brought supercomputing into the personal AI era.